So now we're going to have a panel on 5, 10, 15 years future of our field. And the panelists are myself, Serge Belongie from Cornell Tech, and we'll have Nikhil Rasiwasia, who was previously at Yahoo and now is, he had a small company that got acquired by Snapdeal, which is in India. We also have Stacey Svetlichnaya, who studied symbolic systems at Stanford and now is at Flickr. And finally, we have Ramesh Jain, who is a veteran of several startup companies involving computer vision and multimedia. He's been a professor at several top universities. He's currently at UC Irvine, and he is the co-founder of Crumbs most recently. And our panel will be moderated by Taylor Davidson. Take this one. Cool.
Okay, perfect. Why don't we start by just going down and giving a couple sentence introduction of who you are and kind of what you work on. You want to start down? We'll start with Ramesh.
My name is Ramesh Jain. As Serge said, I'm not sure what I want to be when I grow up. I'm a professor, but at the same time, I enjoy startups so much that there is never a time when I'm not involved in at least one startup. Another aspect that I would like to mention is I started working in computer vision when we did not have cameras, then we did not have processing power, and then nowadays we are working in the area where we have everything possibly in abundance.
Hi, I'm Nikhil. Flown all the way from India for this conference here. I did my... Thank you. So I'm a computer vision researcher. I did my PhD in that area, and post that I've become more of a, at least I want to become a product person now, in the sense, I believe, what has happened with technology, especially with computer vision, is it was supposed to make our life simpler, but somehow it still takes up a lot of mind space, using a mobile phone, I do get irritated from time to time. And I think, now is the time to design right, things using these new technologies so that life can actually become simpler.
I'm Stacey. I work at Flickr on computer vision and machine learning. I've been working mostly on image search and discovery, and I'm generally interested in how the brain processes images and getting computers to work more like the brain.
Once again, I'm Serge. Okay. Is this working? All right. I'll introduce myself here. Serge Belongie. I'm a professor at Cornell Tech. Cornell Tech is the technology-focused campus of Cornell University, which is under construction right now in New York City. We're in temporary space in the Google building right now. And I have one foot in academia and one foot in the entrepreneurial world. I've always worked in computer vision and machine learning, and I've had several students from my lab spin off startup companies involving computer vision and machine learning.
So the major thing we want to talk about is, there's a lot of things we talked about so far, and the rest of the day will be around a lot of the technical aspects of computer vision. And the goal of this one is to think about how it's going to, how the technology will impact our lives, how it will impact business, impact our lives. But I want to start off by asking this question: do you think people understand what computer vision means, right? Meaning, average people in terms of in the media or the workplace or whatever. Do you think we understand what computer vision means? And this is open for anybody.
A few years ago, I think there was a lot of confusion about what computer vision is. Slowly, in the last few years, because there are many applications of computer visions coming in, people have started at least on surface understanding what computer vision is. I think a more important question is, do people working in computer vision area understand what computer vision is? Because until very recently, most of us considered that computer vision means you are getting data from a camera and you are trying to analyze that data itself. without any other sources of data. And I think that was the biggest problem. The day we realized that our eyes don't exist in a vacuum, they exist along with all other sensors and all other knowledge sources, life becomes much simpler.
Anyone else want to add?
Yeah, I mean, I would want to add, like, I am, I'd say, 12 years old in computer vision. And when I entered computer vision, it was different. And in the past 4 or 5 years, I can see the word computer vision being used in blogs and newspapers back in India. Even my mom knows computer vision now, right? But for them, computer vision is recognition to a degree, right? What has deep learning changed in the last 4 or 5 years is they equate deep learning to computer vision to a degree, right? It's becoming recognition and finding objects and imaging. That's what is being equated for a non-computer vision specialist. That's what I think is the more common pulse of computer vision out there.
Yeah, do you think that this is something that is like overhyped by either people who don't understand it or the media, or do you think this is like properly understood in terms of the impact it can have?
I would say, is this working now? Oh, great. I would say that computer vision is maybe close to being overhyped, but it's nothing close to AI in general.
Right.
AI as a field, like if you follow, for example, Jan LeCun on Facebook or Twitter, there's a huge amount of popular science or just general articles in the literature about AI and whether it will take over the world and Skynet and so on. And computer vision doesn't get that same kind of exposure, which I actually consider to be kind of a blessing in a way. It's viewed as one kind of sensory modality that goes into AI. But I think right now I'm just glad that it gets the kind of recognition that things like computer graphics used to get. Everyone knew what computer graphics was when I was in grad school, but people didn't know what computer vision was. So I would say it's hyped, but not overhyped.
Got it.
I agree that AI is a lot more overhyped than computer vision, but just from experience in Flickr, there's still a lot of confusion about what computer vision can and cannot do. So, for example, I think a much more popular opinion is that we can recognize dogs or cats in images very well, but then when users see this, they might get confused as to why the algorithm can't tell that this is a dog or a cat. So there's still not a popular understanding of how the object recognition works and what kind of noise in images or lighting or different angles might cause very basic errors that to a human are incomprehensible.
Yeah, what's interesting to me is like we read all these articles around computer vision, how it's going to impact businesses, how it's going to change the world. We read these things. That's the whole point of our conversation today. But when we see these things, we see a lot of very specific applications of computer vision, which is based upon what we see today, right? Do you feel that this is justified, or do you feel like this is fair in terms of what the true potential for computer vision has to basically change the world?
I have exactly opposite opinion. I think computer vision applications are only in their very early stage. And in that respect, we are not at all hyped. What is hyped is the deep learning applications, because deep learning people need some concrete, compelling example. And there is nothing better than computer vision to demonstrate how well deep learning is working. And that part is there. But if you analyze that, for us, the visual information is the most dominant information. 2/3 of our brain is dedicated to processing visual information. When we consider this, and when we consider all kind of applications that you can start thinking about, then you think that the recognition applications that we are talking today are a lot more influenced by tagging applications that started becoming important in the last decade because of the search engines. What is going to happen in future is going to be really very innovative applications. And some of them you started thinking, hearing this morning, and you will hear a lot more new kind of applications that are coming. I just want to make one important statement that is, I find very intriguing, and I read it somewhere recently, that languages divide us, vision unifies us.
Yeah, I'd actually like to add, I believe it's a little overhyped. as computer vision. So I have two, on one hand, I'm very happy that, people, as Serge was saying, computer graphics, everybody knows what graphics is, and how it helps us. So that change in mentality, or that awareness has happened what computer vision is. But at least, back in India, I see a lot of companies being acquired which do computer vision. But I personally don't think they are, doing enough for those companies to, make them very useful, right? So in that sense, companies believe computer vision can solve a lot of their problems, and they tend to go for these vision companies. But are they actually helping in the business? That is where the overhypedness is a little bit there. Mm-hmm. I believe that they think computer vision can solve a lot of their problems, but which it is not right now. In future it would be, but I just hope that that hype continues and vision catches up and solves those problems actually, versus just being a tool which will solve it in the future.
I think one of the biggest challenges is, as mentioned, that vision unifies us, but language divides us, is how does that system interact with a human user? And a lot of the times that's still using language and using an interface. And I think, once we've solved the challenges of actually identifying the images, how do we communicate the meaning of the image to a user, and how do we use that in other applications? And also context awareness, that we don't just need the logic of understanding what's in the image, but everything else around it. That vision in us is not a standalone system, but uses a lot of knowledge about the world.
Yeah, Serge, you've actually talked before about how visual technology can not only be a tool to kind of help businesses, but also a tool to help people. Would you care to explain a little more on that?
Sure. I think one example of this is this company from Israel called Orcam. And for those of you that haven't seen it, it's a pair of glasses that, this is actually not for blind, but for low vision people. So it's a pair of glasses that has a small camera and some embedded processing to do basic kinds of object recognition, text recognition, and processing of traffic signals and so forth, like crossing a street and so on. And these are just the humble beginnings of commercial offerings for assistive technology. But I think these types of applications are very important for balancing the narrative. Like Evan said in the beginning, with cameras proliferating, the Internet of Eyes and so forth, there are some potentially terrifying implications of having cameras all over the place that can overshadow what computer vision and machine learning can do for everybody. And it's not just for the disabled. Everyone who visits a foreign country who doesn't speak that language is situationally disabled. They can't read the menu. They don't know what the signs are saying to navigate around a building. And I think sometimes people's exposure to technology is through little features of Snapchat or things that might seem frivolous at first glance, but the truth is that they're gaining an awareness of what computer vision and machine learning can do, and that influences the dialogue. It gets people to say, oh, if it's able to do this, if it's able to read text on a Japanese menu, can it also do this for me? Can it help me in some way? So I think I am concerned about privacy implications or just this general worry of too many cameras pointing at too many things. But companies like Orcam, I think, represent this really wonderful aspect of what we're doing, that it can help people.
Yeah, what do you think what happens when we truly understand, like we see computer vision being applied in the world, right? As users, as people, how do you think people will respond to the research or the applications of it being used once we understand, I guess, people, kind of what's going on?
I mean, I see the same thing with speech recognition. I mean, like Ramesh was saying earlier, the deep learning researchers need large data sets and compelling applications to drive home the points of what's possible with deep learning. Speech recognition, machine translation is one of those. Computer vision is another. And what's happening is that these technologies, at least within it's easy to forget that computer vision has more to it than just recognition. I mean, Larry reminded us of that. Nikhil mentioned this also. But when things like Siri and other kinds of dictation software, text, speech to text, start working in a way, they cross a threshold where it becomes magic, we take it for granted, then there's this sort of strange backlash period where we get upset with it for not working better. Whereas within academia, we're just completely blown away by what's possible. So I think right now, we're still in a phase where probably speech dictation is probably considered, that's ready to be used front and center. More and more things like Siri-based interfaces are coming out. Computer vision is still appearing a little bit like a gimmick in a lot of services and cloud-based services, photo storage, and so on. Nikhil may talk more about using computer vision for fashion later. These are things that are still not front and center. They're things that are a little bit at the periphery. People know that this kind of thing is possible, but it's not ready for its close-up the way that speech recognition is. So I think probably at next year's summit, we'll be able to check in on the temperature of that again. But I think we're still kind of in a gimmick plus phase, an exploratory phase in that regard.
Yeah, and I completely agree to that. And I think what right now is needed is computer vision has reached a stage that you get some accuracies, which makes people happy, right? They get wowed by the solution, And so I did something in the lines of fashion, right? And a simple question, right? I mean, if I'm looking at a T-shirt or something which has a pattern, would I want to look at something which is similar looking, right? The generic answer is yes. Before making a purchase decision, I would want to know what are the different price points for similar looking items, after filtering and all, right? And I think the technology is good enough to solve that problem for the user, right? But with computer vision, we just can't think from a technology point of view. We have to think from a human-centric point of view. How can we give it to the user in a form that the user can consume it? How can we make technology not being present in that application so that it's very natural for the user to take it up, right? And I think that's what is missing from a product point of view, leveraging these technologies and making something so seamless that it is no longer a gimmick, but actually becomes of use, right? And that, I hope, again, happens in the next year or so that companies are able to make use of these technologies the right way to solve a problem rather than just being a gimmick.
There is a very interesting trend that Nikhil mentioned and Serge started. If you look at just one photo and try to solve the problem, it's very difficult. If you start bringing in context, and you started seeing right from the beginning today, people talking about context. If you start considering context as part of the photo, and luckily with the smartphone, whenever you take a picture, you are capturing enough context that it is not just a photo. Photo should be considered part of the whole event that you are trying to capture. And that becomes, using the context, you can do a lot more analysis. So the picture that comes in, combined with the context, it starts telling you a lot more about what you could be looking for. So taking Nikhil's example, if you are looking for a picture and the system knows your context, in which context you are looking for, then the search will be much easier for that. And if the system also knows that Nikhil is looking for this, then it starts taking you one more step closer to what kind of things you are looking for. So context becomes the key to some of these things.
Guys, so we talked about product applications, right, and more discrete product applications of it. Where do you think a lot of the research is going to go? What's the big unsolved problems in terms of computer vision out there right now?
So I'll just describe one possible way of framing what I think is an important research problem. So let's put this in context of text-based search. Most of us use Google when we want to know something, we want to learn something. You hear a term, you hear about a historical event, a person. So in the world of text, you go to Google and you type in a keyword, you type in a phrase or a question, and you get back all kinds of interesting information. And chief among those search results is probably Wikipedia and other probably authoritative results. And the subtext when you do that search is It's as if you're saying, computer, tell me something I don't know. Tell me something I don't know about audio engineering. Tell me something I don't know about technology summits. You enter these keywords and you expect the computer to enlighten you, okay? If you look at the state of the art in computer vision right now, which again is focused very much on recognition with data sets like ImageNet and COCO, we are not telling the user something they don't know about the image. Okay, you say, okay, there's a picture that has some bananas and it has a bicycle, and you create this incredible deep learning architecture, and it tells you there is a banana and a bicycle. Okay, so from an academic perspective, that is incredible that we are able to do that. And being able to do that quickly is actually very important, because on a self-driving car, it may be the case that in this frame of video, the presence of a pedestrian is trivial to determine. It's still very helpful that it tells you that quickly. So I'm not saying it isn't important to answer these obvious questions, but we are at a stage where people are not asking the computer to tell them something they don't know about the image. Now, Larry touched on this issue with visual question answering, and it highlights the importance of this interactive way of querying with images, that people do want to know fine-grained things about content in images. Now, the problem is that this requires expertise. It requires access to knowledge that small numbers of people possess. And it's not obvious, given a single image, what somebody wants to know about it. So Stacey mentioned the importance of context, so did Ramesh. Context is not evident simply through uploading an image. Some kind of discussion is needed, some kind of relevance feedback, reinforcement learning, some interactivity. And Larry was talking about these possible research directions. I think he covered a lot of these possible areas where we'll need to explore. But I would say, the simple thing I want my research group to think about is this question: when users snap a photo, when they submit a photo, ask yourself, make more of a demand on the machine. Say, tell me something I don't know about this image, and make it especially relevant to me, given what you know about me, given my profile, given my history, and so forth.
So, you want to answer?
Yeah, not answer, but add to that. What is being discussed is a photo alone enough? What is really happening is that when you capture a photo, you are really capturing a moment which can be represented as a document, which is a lot more information associated with that particular thing. Your example of search engine is very relevant here, because search engines, if they were only string matching, that they were in the early stages, could not answer the way today's Google answers the questions. They started answering all these questions because they started looking at the document, did all the text analysis. They also looked at who posted this document, where this document is coming from, and all this information is being used there. Our photos currently are, each one is independent photo. And even in that, all that we are trying to do is to go and recognize the objects. And then we are trying to search those based only on those objects, which is definitely a big, big improvement. But in terms of understanding those photos, we have a long way to go.
Yeah, so talking, just to add on to that, I want to actually take a little bit different direction of so how do we inspire people to do those things, to do those sort of research? How do we bring more people to work on computer vision? And I actually want to start with Stacey.
Yeah. I think that the tools for working with deep learning and computer vision are becoming more and more available with open source frameworks like TensorFlow and increasingly available data. All of the resources are there and becoming more accessible. And what we actually need to do is try to bring more people into the field, whether that's engineers who aren't currently working on research or people who might be interested in engineering and building solutions to these problems, and sort of present it as a field that's obviously very exciting, but also where it's possible to make a huge difference easily now and build on all of these resources that are being consolidated.
So just kind of carrying forward on that, right? So like a lot of the applications that we talk about are usually very they come from a certain set of like one thing that came up in the terms of when I asked questions for you guys around computer vision, like a lot of examples and things came up were very based on market-driven approaches, like the idea of like gimmicks are the things we work on now, right? So like how do you think we'll shift to working on bigger issues that kind of at hand, like bigger industries? Like what other applications do you think we'll work on outside of that?
So, I mean, I think so computer vision right now, I think what is going well for it is, as Stacey also was saying, that there are a lot of open source tools, right? There are a lot of APIs. Every big company has launched its library you can use and make products, right? And so moving forward, this will be used, to something. There would be someone, I believe, who will tune all these aspects the right way and make something big out of it, right? What's big that's gonna come? I mean, I'm at loss of ideas right now what that's gonna be, but I'm sure we are at the right junction that some guy will come and say, hey, how do I tune all of these the right way and find that problem, which solves it in a bigger picture?
Well, I think that there are hard problems that are also urgent in terms of we need people to work on them, and I think that's some efforts like that are starting. For example, looking at environmental data and climate change. It's like going in and out. And even analyzing satellite imagery to have sort of more of the computer vision resources and work being devoted to helping the world and helping deal with global problems, as opposed to very specific product-driven, market-driven approaches like image search.
So one example of long-term application, I'm interacting with some people in Sri Lanka, and the application is the following. Farmers, they don't understand what kind of diseases their crops are having. What are the bad conditions there? They are all having smartphones. All that they are supposed to do is to take the picture. This picture is automatically uploaded to central servers. There are some recognition algorithms, but many times people are analyzing those things, because the hope is that very soon we will start having the automatic recognition techniques for what is going on there. Based on this, they can predict what kind of diseases are spreading in crops, which particular farmer needs to take care of what particular things, and how good the crop is going to grow nationally, so that they can start deciding in the marketplace what is likely to happen. Fertilizer companies and insecticide companies already started working with the government there, so that they can start supplying these things in time. Everything starts with a computer vision type application there. Mm-hmm. But the system works because system has all the context. Which particular farmer is sending the information, where the farmer lives. Using GPS, they know where the picture is being taken, what kind of crop this particular farmer grows, and what are the atmospheric conditions.
So actually, we have a couple more minutes left. I want to make sure and give people a chance to ask questions. Do we have any questions from the crowd?
Check. There we go. Peter Krogh, Photo Shelter. I think what you guys are getting at here to a large extent is moving beyond recognition and context into meaning. And, photography is becoming a visual language, or, a language in and of itself. And it's not all about AI. It's also about linking to data like I can know that an address from a GPS tag is this address, but the meaning can come from knowing that that is my parents' address. And so I'm wondering if you can talk about how meaning fits in with this.
In fact, that's a very good point you are making. What happens in many of these systems is that from GPS, you can do reverse geo to find out what kind of place that is there. What is really missing is, can we find the intent of the person who is taking the photo? Because without intent, you cannot really completely analyze why or what is the meaning of the photo. Capturing intent is really a lot more challenging problem when you try to analyze pictures.
And as Serge was saying, we are working on improving the relevance of the search, and that's in many ways doing very well. We can find photos with specific objects when you already know that, but what kind of photos do you actually care about? What kind of photos do you share with family or with specific people? That's a much harder problem and requires a lot more personalization and context awareness.
Building on that point, it seems like looking at the computer vision in a 10-year time frame, we often see 10 years go by and the data that is sort of taken for granted now can just be dwarfed by the data that's coming 10 years later. So 10 years ago, there was no real smartphones. So there wouldn't have been GPS. There wasn't internet connectivity in the same way. There wasn't the same scale. I'm sort of wondering, for the people on this panel, if you could go back 10 years or 20 years and tell yourself something about, oh, you should focus on this and not on this, because in 10 years, what you're analyzing is going to change. Do you have any thoughts on what was maybe overemphasized 10 years ago versus where things maybe are even going in 10 years?
Being oldest on the panel, I think we have seen a very interesting transformation in computer vision, starting from not having good cameras to processing to now. As had been pointed out, deep learning has been so successful because we have a lot of data and lots of processing power. What is going to happen soon coming in is we'll have a lot more context. When you are taking the picture, you have enormous amount of context, not only from your phone or from your camera, but also through all the IoT devices and all those things. And these things will become part of your photo. And can you find out things like intent? Possibly you will start doing that through wearable devices and understanding your emotional state and things like that. But then will come, in my opinion, the next step, which will be truly revolutionary. Right now, we are considering each photo to be one thing. We know that World Wide Web happened because each document is connected to all other documents. Can we start creating a web of all these things? Maybe web of events that are all connected to each other. Because ultimately, by connecting different events to each other, we will start understanding the relationship among those and why is what's going on, what is happening. We can start understanding situations. That's what will happen.
That's probably a perfect way to end on. So I want to thank everyone here for the panel, and I really appreciate it. Thank you.
Applause, folks. Thank you very much, Taylor, and everybody on the panel. That was fantastic.